Okay, we're going to continue to ask the question, what is the name of the reactant and the product of this reaction? The name of the reactant and the product of this reaction. Again, write down your answer, and then we'll see what we can say. First of all, the name is trans-3-hexene. There's 6 carbons. The double bond is right in the middle, and both hydrogens are on the same side, and that indicates to you that both of the methyl groups would be across from each other. If I were to show this on a quiz or test, I would make it more obviously trans so that it wouldn't be difficult for you to figure out what it is. Now, you've also written down the name of the product. And the product is going to have a chlorine at each of the 3-point and the 4-point. So this is going to be hexane, ANE, and it's going to be 3,4-dichlorohexane. 3,4-dichlorohexane. Now, we're going to move on and talk about a triple bond. And the triple bond, the name changes by using YNE instead of ENE. So you had ethane, then you had ethene, now you have ethyne, which is also known as acetylene. And in this case, you have a triple bond between the 2 carbons. So an alkyne is a hydrocarbon molecule with 1 or more triple bonds. This is the simplest alkyne, ethyne, and is also called acetylene. The alkane name is used with the suffix YNE instead of ANE. And so you count the carbons. If it has a triple bond, then you use the suffix YNE instead of ANE. So here we have 1, 2, 3, 4. So this would be butane, but it's got a triple bond, so it's butine, B-U-T-Y-N-E, and it's in the middle here, and so it's going to be 2-butine. And then it could have the geometric cis or trans as well. But what is the hybridization of the carbon here? If you remember, the hybridization is going to be sp. Carbons 1 and 4 are sp3, but carbons 2 and 3 are sp hybrids. So what is the hybridization and bond angle for the carbons above? Carbon 1 has got a triple bond, so it's sp with carbon 2, sp. It has sp3 or sp2 with carbon 3, sp2 with carbon 4, sp3 with carbon 5. Carbons 1 and 2, sp, and it's 180 degrees. Carbons 3 and 4 are sp2, 120 degrees, and carbon 5 is sp3, 109.5 degrees. Now, I'm not going to ask you questions about bond angles in this group of lectures. Now, you can also have substitution reactions with the alkynes, and in this case, you can see that you take 2 bromine molecules, add it to alkyne, you end up with 1,1,2,2 tetrabromoethane. The last thing we're going to talk about today are aromatic hydrocarbons. Aromatic hydrocarbons are ring structures that have 3 double bonds, alternating double bonds. This is what's known as benzene, and this shows the 2 resonance structures between the 2 in the benzene molecule. So an aromatic hydrocarbon is a compound that has a ring structure and exhibits bonding that must be described by using a resonance structure concept. And there's a delocalization of electrons in this situation. And one way to represent this is just to put a circle in the middle that represents the delocalized electrons. So the 3 valence electrons in the sp2 hybrid orbitals for each carbon atom and the valence electrons for each hydrogen atom form a framework of sigma bonds in the benzene molecule. The 4th valence electron in each carbon is shared with the adjacent carbon in their unhybridized p orbital to yield the sigma bonds, and those 3 valence electrons are delocalized. And so in one way to represent this delocalization is to put a circle in the middle as it's shown here. And this is one of the ways of representing the structure of benzene. Now there are other compounds that are made from benzene, and the important ones are shown on this side. On the left, you have a single methyl group off to the side, and that's called toluene. The second one has 2 methyl groups right beside each other, and that's called xylene. And then on the right is a ethyl group with a double bond, and that's called styrene. And the reason I bring that up is something known as polystyrene, which is an important compound used in plastic. Now you see here you have one of 3 isomers where you substitute a chlorine on toluene, and this is called 3-chlorobenzene or metachlorobenzene. Now the other 2, it says what are the other 2? The other 2 can be, you can move the chlorine toward the CH3 so that they're right next to each other, or you can move the chlorine away so they're opposite each other. And those are shown here. On the left you have the chlorine right next to, and on the right you have them opposite each other, and they each have a different name. On the left is 2-chlorobenzene or orthochlorobenzene. Remember the one on the previous slide was called meta. Either name is correct. So 2-chlorobenzene or orthochlorobenzene, and then the bottom one, or the one on the right, is 4-chlorobenzene or parachlorobenzene. And here's the same situation where you substitute benzene with bromine. Now I did make a mistake in this previous, these should all be called toluene instead of benzene because you started out with toluene, a substitution of toluene. I'm sorry about that. I just realized that as I was talking here. Here is the substitution of bromine. On the left you have ortho-dibromobenzene. In the middle you have meta-dibromobenzene, and on the right you have para-dibromobenzene, or 2,3-dibromobenzene, or 1,3-dibromobenzene, or 1,4-dibromobenzene, or ortho, meta, and para-dibromobenzene.